The ballistic pendulum is another illustration of kinetic energy versus potential energy. One of the bodies, the pendulum, has a much larger mass than the other body, the bullet. After collision, A and B share the same movement. So, we have to find just one final velocity. Conservation of momentum is enough. Conservation of kinetic energy wouldn't be of any use, as we shall see later. As the velocity of body B, the pendulum, is null, before collision, it's easy to relate the velocity of body A, the bullet, before collision, with the velocity of the pendulum with the embedded bullet, after collision. The idea behind the ballistic pendulum was to deduce the initial velocity of the bullet, from the height which the pendulum attained, after being hit by the bullet. While the pendulum swings for the first time, kinetic energy is transformed into potential energy. When the pendulum attains its maximum height, h, all its kinetic energy, EC, has been translated into potential energy, EP. The velocity of the pendulum after being hit by the bullet is easily related to the maximum height it attains. In low gravitation, the pendulum has to go higher in order that the potential energy can equal the value of the kinetic energy that disappeared. In high gravitation, less height is necessary. We have, now, all we need to deduce the velocity of the bullet from the height attained by the pendulum. Insert the value of the velocity, v, of the pendulum, right equation, in the left equation. There you have it. Now, let's deduce the maximum height of the pendulum from the mass of both bodies and the velocity of the bullet. Both formulas are useful in their own way. Note that, when the velocity of the bullet doubles, its energy quadruples, and so, the corresponding height attained by the center of mass of the system pendulum plus bullet. Please, try this question. A bullet of mass, 20 gram, and velocity, 1000 meters per second, is fired against a pendulum of mass 5 kilogram. Find the maximum height, h. Find the length of the pendulum if its maximum deflection is 45 degrees. Just insert values in the formula. Note that the height will be lower if gravity, or another force that pulls down the pendulum, is stronger. Notice that L is the radius of a circle. L is equal to L multiplied by the cosine of the angle, plus the height, h. You can generalize the previous situation. Note that, if the pendulum is longer, the deflection will be lower, for the same height. The height reached by the pendulum does not depend of its length. It only depends of the energy brought by the bullet. The longer the pendulum, smaller is the deflection needed to reach the maximum height.
Let us relate the initial and the final kinetic energy of the system bullet plus pendulum. Note that the pendulum does not contribute to the initial kinetic energy, since its initial velocity was null while the bullet had velocity vbu. After collision, we only have one velocity, that of the pendulum with the embedded bullet, vpd. Let's divide the final kinetic energy of the system by its initial kinetic energy. But, first, replace the velocity of the pendulum by its value, as function of the velocity of the bullet. Note that, increasing the mass of the pendulum, has the effect of lowering the mechanical efficiency of the collision. See how the mechanical efficiency of the collision, between the bullet and the pendulum, decreases, when the mass of the pendulum, increases. If the mass of the bullet equals the mass of the pendulum, efficiency will be 50%. If the mass of the bullet is much lower than the mass of the pendulum, efficiency approaches 0%. If the mass of the bullet is much higher than the mass of the pendulum, just when you walk under the rain, efficiency approaches 100%. If the mass of body B, the pendulum, is much higher than the mass of body A, the bullet, the loss of kinetic energy will be virtually total. This is the situation when we throw something sticky to the ground. Think about the huge mass of the Earth.
See you in the next video. One-dimensional collisions, equal masses.